This is LEGO Albert Henry Munsell. And here's LEGO Gunter Wyszecki and LEGO Richard S. Hunter, two of the color scientists whose work led to the creation of C-Lab. They're showing off their C-Lab plot of 48 LEGO colors to Albert Munsell. He's pretty impressed by it, but LEGO Isaac Newton is kind of mad about it. Not really sure why. I mean, there's always some kind of drama with this dude. It's Color Wheel Wednesday, and as a color nerd, as well as a longtime LEGO fan, I've frequently wondered if I could build a LEGO color wheel. And it turns out I'm not the only one who's had this thought. For instance, here's a color wheel by Niels Boog. You can see that it's based on Johannes Itten's color wheel. It's got red, yellow, and blue primary colors in the middle, and 12 hues spaced so that red, yellow, and blue are 120 degrees apart on the circle. And here's a more complex iteration of the same concept by Chris Behrens. Behrens seems to have expanded the wheel to 24 hues to include more color variations, but the colors are not in hue order. This pink, for example, is on the wrong side of this violet. And then there's Galactech on Flickr, who says the purpose of his wheel was to remind himself of the range of colors he had available. His design includes a bin for 1x2 bricks that can act as swatches in brainstorming palette arrangements. And he says, having this on my desk is a good source of inspiration. I arranged the colors to my subjective perception, but I'm sure it could be done more scientifically. More scientifically, you say? Yeah, maybe a color wheel isn't the answer. Maybe we need something else. A thorough scientific reference to assist with color selection, order, and coordination. Has anyone done this?
My name is Christoph Bartneck. I'm a professor at the University of Canterbury. I teach information visualization, but I also previously worked for the LEGO company, and I'm deeply obsessed with the brick and its color, and I'm the author of the Unofficial LEGO Color guide.
So you're the right person to ask. Why is there no official LEGO color wheel or guide or list?
The most obvious answer to that is the trade secret. So they want to make it as difficult as possible for other manufacturers to make bricks in the exact same color that they do.
Right.
And they're a private company. They've got no obligation to reveal this information, so it's all good.
For fans, they could at least publish a list of colors, couldn't they? Like, without the specifications?
They, I think, at least twice released a color sheet with information on it. They also have software that they make available, and in there you can just, color pick the RGB values. But this information is not consistent.
I noticed this myself when taking Bricklink Studio for a spin. Often the color shown on screen is very different from the actual color of a Lego. Here's bright light yellow, for example. So for the LEGO community, how important is a thorough, up-to-date documentation of LEGO colors?
If you want to build your own models and you want to do it at scale, you need to first know what colors are available.
And resources like Bricklink have all the current production colors listed. There's about 50 of them, but some of them are only used for specific things like skin tones.
But if you want to do more exotic stuff, then you might want to use colors of bricks that are not currently in production.
For example, if you're building a 1990s style spaceship, you'd want to find the warmer gray bricks used at the time, which were replaced by cooler bluish grays around 2004.
But again, there's a difference between practical colors, so colors that you can get bricks in quantities that are sufficient for you to build something, versus some sort of more historical colors, like if LEGO did in the 1980s produce a particular color for a very small number of bricks. Is that really relevant right now? Well, for a collector, yes. For somebody who builds something right now, probably less so.
Including those discontinued and obscure ones, Dr. Bartneck's book catalogs over 200 LEGO colors. For most of the solid colors, that is, colors that are not transparent or glittery or metallic, he includes colorimetric data, RGB values, which are approximations, and LAB coordinates, which are more exact. But lab, he acknowledges, is kind of technical for the average person.
I see from education perspective that people probably more easily relate to RGB because it's in their TVs, in their phones, and
right.
But on the other hand, if you are a bit more interested in color, then that is important for the professionals. So my strategy was just give people options so that they can pick whatever is most suitable for their particular scenario.
For my own particular scenario, it turns out LAB coordinates are just what I need. You see, I've got something I'm itching to build, but to explain why lab is perfect for it, I first have to explain what lab actually is. C-Lab was published by the CIE, the Commission Internationale de l'Éclairage, in 1976. The scientists involved were trying to solve a specific problem. We already had a way to write color down as numbers, or coordinates. That was the 1931 system, built from a small number of color matching experiments. That system uses abstract imaginary primary colors, X, Y, and Z, to create a mathematical space where all colors in standard human perception can be charted. But the problem was, on the 1931 diagram, the distance between two colors didn't translate to the visual difference between two colors. So two greens a given distance apart look almost identical, and two blues the same distance apart look obviously different, for example. So the scientists worked out some equations that squashed and stretched the map until equal distances meant roughly equal differences. Emphasis on roughly. It's not perfect. And the blues especially get sort of stretched out in a wonky way. Improvements and newer models are out there, but those can get kind of technical, and none of them have been universally adopted. C-Lab is close enough and useful enough, so it became the standard. Plastics, cosmetics, high-volume printing, lab is used everywhere in all these different industries. L star, A star, B star is an abbreviation of lightness, A-axis, B-axis. The asterisks, by the way, were added to distinguish these CIE color measurements from the original LAB measurements proposed by this guy, Richard Hunter, in 1948. But most people just find it easier to drop the stars in conversation, so lab. Anyway, what are L, A, and B actually measuring? L star means lightness on a scale where 0 is absolute black and 100 is screaming white. That's easy. Looking at the AB grid, the point where both A and B equal 0 is a perfect gray of any lightness. A is the longitude. The higher the A value, the more strongly red or magenta the color is. Negative A gets greener and greener. B is the latitude. The higher the B value, the more strongly yellow. And negative B gets bluer and bluer. Put it all together, you get the AB plane. That's it. Now you know how lab works. And here's why lab is exactly what I need. I'm going to try to build a LEGO color space. And, not this dinky one, which is too compressed to be accurate and doesn't include the dimension of lightness. I mean a serious, three-dimensional model. And the thing is, so many of the color models we've talked about in this series are round. Munsell, Ostwald, and so on, because in those systems you're organizing based on hue, which is measured as an angle around a circle. That's why color wheels are a thing. But Legos are modular bricks, and if I want to build a Lego color space, I should really do it as a grid, not as a circle. Sorry, Newton. So for that third dimension of lightness, I figure what I'll do is stack bricks. These clear soda cans can make columns for each of the different data points, like this pink, for example. I can put at the top here, and this would indicate 1, 2, 3, 4, 5, 6, that it has an L star or lightness reading of about 60, like round it to 60, and then we'll put it on the base plate. So my next step was to build a proof of concept in Bricklink Studio. And what I did was, for this one, I used a 32 by 32 base plate. I thought that would probably be big enough. But what ended up happening was the math of converting lab coordinates into stud coordinates wasn't the best. I ended up having to sort of like nudge things over so the towers didn't collide, and like the positions weren't super accurate. So I decided to go for a 48 by 48 base plate. All right, so I'm about halfway done. Most of my bricks have come in the mail, some have not. So I'm just working with what I've got. I have about 48 colors. So this is Vibrant Coral, and its stud position is A17B7. 1, 2, 3, 4, 5, 6, 7. Ta-da! So as I'm working on this, a couple quick notes. You can see where I had to get creative a little bit. So like some of these are off-center so that they can stack right? This guy's A-B position was very similar to this guy, even though they're very different lightnesses. So he's kind of like connected on the corner. Some of these I actually had to stack, like white and the old warm dark gray are on the same A-B position. Also, you can see, like, here's one of the discontinued colors I found in my collection. This sand red, I think they stopped making it about 20 years ago. Also, a few of the current production colors were so new, like they just came out in 2025 or 2026, that there was no lab data for them in Dr. Bartneck's book. So I went online, I found RGB values, and I converted them and sort of got an approximation for reddish orange, warm pink, and blue violet. So this is where I ended up. This was a fun build, but could it be a practical, useful resource for LEGO fans who design original creations? I mean, maybe. I could see it being a helpful way of designing limited palettes, for example, to give a model a certain mood. And it's not definitive, but it would be easy to add new colors as they come out. In the end, I think it's probably too complicated to be something the average LEGO fan would want to build and have on their shelf as a reference, but it was a great curiosity spiral for me, and I learned some things, like where the gaps are in the LEGO palette and where the pileups are. So yeah, I loved doing this work. And in the meantime, Dr. Bartneck's work continues. He and his students are currently developing an app.
Why not have an app that you can point the camera at a brick and say, hey, what color is that? We will have a LEGO based target that people can use to calibrate their camera and their environment light, and then take a picture, and then we can hopefully match it, or at least get pretty close to what we believe this color could be. Hopefully by the end of the year we'll have an app that people can try out and see if they can identify all the colors that they have.
How cool would that be? I actually have one last build to show you. This is like a third version. Where I thought, well, what if I could sort of indicate the lightness level by different heights of bricks in the way I stacked them? And actually, I was able to include a couple more colors on here that I couldn't put on my other chart. Like, see this little doggy? That is a yellow ochre color that they literally only make a couple pieces in, including this dog. Anyway, this has been a lot of fun. Thanks for joining me, and I'll see you next Color Wheel Wednesday.